Web Development Basics. About this course. Welcome to the Web Development Basics course. In this course, you'll learn about basic computer functions and programming languages. You'll get an overview of web development, including the scope of the two sides of web development, front-end and back-end. And you'll learn about the difference between the Internet and the World Wide Web. Learning objectives. After completing this course, you should be able to describe the basic functions of a computer, differentiate between hardware and software, describe the types of programming languages, explain how a computer reads code, differentiate between web design and web development, identify website components, explain the main steps in the web development process, differentiate between client-side and server-side processes, identify the focus areas and common languages for front-end development, identify the focus areas and common languages for back-end development, differentiate between the World Wide Web and the Internet, explain how the cloud benefits web development. About this module. Module 1. How does a computer work? Introduction. In this module, you will learn the 4 basic functions of a computer and their significance. In addition, you will explore the architecture of a computer that includes physical and conceptual layers. Finally, you will understand the importance of each layer, their role in executing computer programs, and how they relate to web development. Learning objectives. After completing this module, you should be able to explain the 4 basic functions of a computer, differentiate between hardware and software, explain how web pages and web applications work in a web browser, an overview of the basic computer functions. Computers do everything from tracking your steps to helping NASA explore space. The first computer weighed over 27 tons. Now, they are small enough that you can wear one on your wrist or put it in your pocket. No matter the size, all computers have 4 basic functions: input, processing, output, and storage. Let's take a look at how these functions work in a computer. Input. Getting things started. Inputs are information received by a computer. A computer cannot perform a function until it receives input. Web developers build interfaces for users to provide input through keyboards, computer mouses, or even touch screens and microphones. Computers can also receive input automatically through devices like sensors. The computer must translate the data it receives from the input devices into binary code for the computer to either store or process. Binary code, also known as machine code, is a system that represents all data as either 0s or 1s, or false/true or off/on. It is the only language that a computer can understand. Processing. The transformation. When a computer receives data, in the form of 0s and 1s, it must transform that data. The computer transforms the data into anything from numbers, to letters, to simple commands. Processing is the series of actions that a computer takes when it receives data. The programs that web developers write will tell the computer what to do with the data that it receives. The computer mainly performs logical operations because the data is converted into 0s and 1s. Output. The reveal. Output is the result of the computer transforming input data, through processing, into usable information. A computer's output might be letters, numbers, photos, videos, or audio. Users can receive this output in different ways, including via device screens, speakers, and even external devices such as printers. Similarly to input devices, output devices must do some translation. They decode machine code from the computer into a format that users can understand. Storage. Hold that thought. Storage refers to how a device retains information. Web developers need to be aware of, and need to know how to use, short-term storage and long-term storage. Short-term storage, also called volatile memory, stores data while the device is running. Websites store data that web pages will use while the user is interacting with it. The data is stored in short-term memory, called Random Access Memory, RAM. For example, suppose you're developing a site that handles inventory for a shipping firm. When a customer enters an order, the web page will hold the data in short-term memory until the customer clicks or taps a button to submit the order. In many cases, the web browser will handle storing data in short-term memory. Long-term storage will retain information even after the device is powered down. Devices like solid-state drives, SSD, or hard disk drives, HDD, are used for long-term storage. Websites create small files that store information called cookies. A cookie stores user-specific data such as the last time that the user visited the site, how long before they need to log in again, and other data. The device's long-term storage stores cookies, which persist between site sessions. A session is the time a user is on a website in one continuous block of time. Here's a scenario to help you understand how the 4 basic computer functions work together. 4 simple functions, many complex tasks. It might be hard to believe that the computers that put humans on the moon had only these same 4 functions, but it's true. From early computers to the cell phone, all computers perform those same, basic 4 functions. They take in information, in the form of 0s and 1s, transform that information, store information for a period, then send that information back out to you, the user. The layers of computer architecture. When you hear the word computer, you might think only of the physical devices that you have used, such as your laptop, desktop, or cell phone. But, for your computer to complete the 4 functions, it needs hardware, the physical components, and software, the instructions. Let's explore the layers that make up computer architecture. Hardware is the physical components your computer needs to operate. Examples of hardware include the RAM and Central Processing Unit, CPU, which handles processing. Hardware. Some hardware also functions as input/output, I/O, devices. I/O devices are the physical components your computer needs to gather inputs and share outputs. The keyboard, microphone, and mouse are examples of I/O devices. Software. The primary software that your computer needs is an operating system, OS. The operating system is like a manager. It enables you to communicate with the computer without knowing machine code. It also manages all software and hardware, and acts as a coordinator between the hardware and all systems that are running. Some examples of operating systems are Linux, Windows, Android, Apple Mac OS, and Apple iOS. Other software applications, also called programs, are sets of instructions that the computer uses to perform tasks that are beyond the main functions of the operating system. Examples of software applications include web browsers, word processors, and image editors. You can see that hardware and software are essential for you to use the computer. See if you can identify which items are hardware and which are software. Connecting computers and web development. Computers existed many years before the invention of the Internet. But, as the Internet started to grow, how users accessed programs began to change. The development of web browsers, like Google Chrome, Mozilla Firefox, and Microsoft Internet Explorer, was a critical piece of this evolution. But, web browsers are limited without programs written by web developers. Web programs and web browsers. An automobile is a complex piece of machinery. It has a lot of electronics, an engine that is very powerful, and complicated mechanisms that make it all run. Without a driver, however, it won't do anything, at least not yet. The driver is what directs the automobile and makes all that power come to life. The web browser is like the automobile. It has a lot of power and uses complex software to make the web useful. However, without websites, it really can't do much. The websites and web applications that developers write are like the driver. They tell the browser what to do to make it useful. Web applications are a hybrid between a software program and a web page. Web applications can run in a browser, but many software developers use a wrapper for web apps. A wrapper is software into which a developer can add the code they developed for a website. You might have downloaded an app onto your phone that looks and behaves just like the application's website, such as a to-do list app. The phone app has essentially the same code as the website, but it is delivered and operates on your phone through a wrapper. The following image illustrates the difference between a web app and a web page. While both apps and pages send data to and receive data from the internet, web apps have more access to system resources like storage, the file system, and the graphics processor. This helps them behave more like traditional applications. About this module. Module 2. Speaking code. Introduction. In this module, you will learn about abstraction and its role in computer programming. You'll explore different types of programming languages including machine, compiled, and interpreted languages. You will also learn how a computer reads code and the translation process that enables the computer to read and execute binary instructions. Learning objectives. After completing this module, you should be able to describe abstraction and its role in computer programming. Explain different types of programming languages. Describe how a computer reads code. Explain the compilation process. An introduction to abstraction. Modern personal computers can perform millions of operations per second. For much larger computing projects, the world's fastest supercomputer can perform 1 exaflop, or 1.1 quintillion operations per second. The computer's ability to perform this many operations in such a short period of time enables us to solve complex problems with relative ease. Even though computers perform so many operations per second, humans must code those operations. Developers must manage all the details for each of the millions of operations. So, how is it that programmers can create such complex sets of instructions? Do you need to be a mechanic to drive a car? The concept of abstraction makes it possible to give a computer instruction without understanding the sheer complexity of the machine. Take for example, a car. You can drive a car even if you know very little about the mechanics of the car. You simply get in the car, turn the key or press a button, put the car into gear, and drive. To drive the car, you don't need to understand how the engine uses burning gas to convert heat into the force that propels your car forward. You also don't need to know how the hydraulic system works with your brakes that enable you to stop. The details of how these things work is not essential. You know that to move a car forward, you need to step on the gas pedal, and to stop the car, you need to step on the brake. Abstraction in computer programming. Similar to the car driving example, abstraction hides the complexity of the computer machine and enables programmers to focus on what is most relevant using programming languages. Computers require binary, or machine code, to generate output. But you're not expected to code a website in a series of 0s and 1s. Developers wrote the first computer programs in machine code and assembly languages, also known as low-level programming languages. But over the years, more details of a computer system have been hidden so that you can write code using more natural language elements. These new languages are easy to write, and developers can comprehend them quickly. You will learn about these types of programming languages next, but first, take time to reflect. What do you think? Abstraction is something that is used every day to make our lives easier. What are other examples of abstraction that you use? Can you think of other machines you use in your daily life that are examples of abstraction, like if you make coffee in a coffee machine or toast bread in a toaster? Type your response in the following text box. Writing an answer is a good way to process your thoughts. These answers are for your use only. You have the option to download your response and save it. It will not be saved in the text box when you move on in the course. Evaluate your thinking. Does your answer account for the following? An example of abstraction is taking photos on a digital camera or smartphone. Think about devices or machines where you, as a user, can use the device or focus on its main function without needing to understand all the details. Money is also an abstraction. You do not need to know about currencies, economics, or even the banking system to use physical or digital money to buy goods and services. Types of programming languages. Even though a computer can only understand binary, there are hundreds of programming languages that exist. Explore the types of programming languages. Machine languages. First, the only language a computer understands is made up of binary numbers, 0s and 1s, called bits. These bits can only represent two possible states, such as on and off, or yes and no. While these two states on their own cannot represent much, when you combine many bits together in different patterns, you can represent quite a lot of information. The Central Processing Unit, CPU, of the computer interprets machine code directly. Currently, machine language is rarely, if ever, used to write programs. Compiled languages. These languages are used to develop systems programs, such as operating systems or hardware drivers. They are also used for managing parts of the computer system such as memory and data transfer. Compiled languages are also called low-level programs because they are very close to the actual hardware of a machine. For a computer to use a compiled language, the code a software developer writes must be put through a compiler. A compiler is a mid-20th century invention by Grace Hopper, opens in a new tab, which translates human-readable code into machine code. If you were to look at code after it is compiled, it would appear as a lot of random characters. Compilation usually is a one-way process. After a developer compiles code, they can't modify it. They must go back to the source code to make changes and compile it again. Source code is the version of the program software developers can read and edit. When a compiled program is read by a computer, the entire program is loaded into the computer's memory. As a person interacts with the program, the computer can perform functions from the computer's code that is available in its memory. For example, the most common compiled language is C. C continues to be a popular language because of its high-level readability and low-level functional capabilities. Java and C#, pronounced C#, are other popular examples of compiled languages. Interpreted languages. Interpreted languages are the most abstracted from machine language. Similar to compiled languages, they are designed to be self-describing. Self-describing code is both easily readable by humans, but also the syntax of the code tells the developer what the code does. Interpreted languages need an interpreter. An interpreter is a piece of software that reads each line of code independently and executes them at runtime. Runtime is the code of a program that is active in the computer's memory at a given time. As you learned with compiled code, all the code of a compiled program is available at runtime. Interpreted code is executed line by line. What parts of the program stays in memory is dependent on how the developer writes the interpreted program. Python and JavaScript are both examples of interpreted languages. You can see there's a wide range of programming languages available to choose from. See if you can categorize some of the popular languages. How does a computer read code? So, how does a computer translate the code that a developer types into the binary code that it understands? Computer programs comprise binary combinations of 0s and 1s. You can think of binary like a light switch. When the switch is off, the binary digit is in the 0 state. When the switch is on, the binary digit is in the 1 state. When you only have one switch, your light bulb can only be in one state at any given time, on or off. As you add more switches, you exponentially add more possible states. Now suppose you have two switches that can function as a dimmer for the bulb. With two switches, your bulb can be in 4 different states. In the morning when you're just waking up, you turn the bulb on using state 4. In the middle of the day, you might use state 3 because the sun provides some light. In the evening, you use state 1, and when you go to bed you use state 2. 1 when both switches are on, the light bulb is on full power. 2 when both switches are off, the bulb is off. 3 when switch 1 is on and switch 2 is off, the bulb is on at 33% power. For when switch 1 is off and switch 2 is on, the bulb is on at 66% power. Machine code operates on this basic model, but modern computers can process millions of switches in very short periods of time. This simple model enabled early programmers to develop punch cards to provide the computer with instructions. Punch cards consisted of columns and rows that contained numbers. Early programmers would write out a program by hand, then use a tool to punch holes in each column. Each punched out hole represents a yes state. Each number that is unpunched represents a no state. Each line of code required one punch card. Early programmers would insert each card into a punch card reader, often stacks at a time. As the punch card reader read the cards, the computer memory stored the information. The computer was instructed to execute the code after all the cards were inserted. Explore more. Check out the history of the IBM punched card, opens in a new tab, and how it transformed the world. A novel idea. It's much easier for most people to write an English statement than it is to use symbols. So, I decided data processors ought to be able to write their programs in English, and the computers would translate them into machine code. Grace Hopper, an American pioneer in computer programming. Source: Particular Passions, Grace Murray Hopper, opens in a new tab, by Lynn Gilbert with Galen Moore, 1981. Today's computers do not receive their instructions using punch cards. Now, you can write programs using any number of human-readable languages, such as HTML or CSS, and this is possible using a compiler. While interpreted code doesn't need to be compiled, the interpreter still needs to translate the human-readable code to machine language. Ultimately, all code that developers write gets translated to the machine language the computer understands, either by a compiler or an interpreter. Here is an example of a simple Python program to add two numbers. Take a moment to review. If __name __main__, number 1 equals 15. Number 2 equals 12. Sum _tunum equals lambda number 1, number 2, number 1 plus number 2. Print, sum of 0 and 1 is 2, format, number 1, number 2, sum _tunum, number 1, number 2. When you first look at this code, you might see some terms that you understand. The code also might not seem very readable to you. But when you know the terms the language uses, the syntax, the code becomes much easier to read. The code syntax defines the structure of the programming language and functions like grammar does in natural languages like Greek or Hebrew. Syntax. Syntax is the structure of the programming language and describes the terms and relationships programmers can use within the language. Language translation. Human-readable language gets translated into a language the computer can understand through a compilation process. Step 1. First, the translator, a compiler or interpreter, checks the code to ensure the syntax is correct. It also confirms that the code follows the rules of the language. If it finds an error, the translator stops and provides information to you about what the error is and where it occurred. Step 2. Next, the translator converts the code into machine language. The computer's brain, the CPU, can't use the code until it's in a language it can understand, which is machine language. Step 3. Finally, your computer's operating system opens the translated code, reads the program's instructions, and executes those instructions. Summary. That's how it works. Web developers use a compiler or interpreter to convert source code into machine code, enabling the computer to read the program instructions. About this module. Module 3. What is web development? Introduction. In this module, you will gain insight into web development and its importance. You'll learn about web pages and the key features required for running them. In addition, you'll get an overview of the web development process as well as the difference between client-side and server-side web processing. Learning objectives. After completing this module, you should be able to Describe web development. Distinguish between the web developer and web designer roles. Explain why web development is important. Describe the components of a website. Identify the typical steps of the web development process. Compare client-side and server-side web processes. Overview of web development and web design. People around the world use the web many times a day to do any number of tasks. You are using the web to take this course. Web development includes all the work that goes into building and maintaining web pages and websites. Web development includes writing code to lay out a web page, add fonts and colors, and making the website interactive. Web developers also work on databases, servers, and network configuration, application programming interfaces, APIs, and other server-side software that ensures a website performs correctly. Web design is also an important part of web development. It focuses on how the elements of a web page or website are presented to the user. Information should be easy to find, colors should be pleasant, and there should be enough, but not too much, negative space. Websites and pages should also support great experiences for users with accessibility needs. Web designers do all this and more. While there is overlap between the role of web developer and web designer, they each have a unique role to play in the overall development of a website. Explore the differences between web developers and web designers in the following table. What do they do? Web developers write front-end and or back-end code to make the website work. Web designers create wireframes and prototypes based on user requirements to test design ideas. Who do they work with? Web developers work with the web designer, architect, product manager, and others to build a site based on design and functionality needs. Web designers work with clients or users to translate vision into viable designs, and use these designs to create a site. What expertise do they need? Web developers need to be an expert on front-end and or back-end coding languages, frameworks, and libraries. Web designers need familiarity with some front-end coding languages. Why is web development important? On average, a person spends almost 7 hours a day using the internet. You can use the internet to write emails, organize your calendar, search for answers, connect with friends all over the world, order pizza, and much more. The modern internet is a recent invention and has gone from just a few users at its conception to almost 5 billion users in 2022. Source: Digital 2022, Global Overview Report, opens in a new tab, Data Portal, by Simon Kemp, January 2022. Web development made this growth possible. Without web developers, users would not have informational websites, social media sites, or online stores that are also called e-commerce. Much like humans use computer software to do specific tasks, the internet is also used to get things done, even if that task is watching funny videos. Without websites, and many of them, humans would not have a reason to visit the internet. Web developers are necessary for building and maintaining the websites and web applications that people use every day. What is a website? You might think of a website as a collection of web pages that are all located on the same domain name. That's true. And now, you'll dig a little deeper into what a website is and how it works. What is a web page? A web page displays information on the internet in the form of text, copy, images, videos, and other elements. Web developers create web pages. They use specific coding languages to program a set of files. These files describe various components of a web page. The layout, the content that should display on the page, and the media types to use, such as audio, video, images, and more. The style of the fonts, colors, and media on the page. The numerous ways that a user might interact with the web page, such as links and buttons, and advanced methods of interaction, including login and password authentication. In addition to web pages, a website also needs a domain name to locate it, a browser to view it, and a server to host it. Take a look at the essential components that are required for a website. The domain name and URL. If someone told you they live in Tokyo, you could infer the country they live in from the city name. The same goes for how we communicate web addresses. When entering a web address, you typically only put the domain name. Most web browsers can infer the entire Uniform Resource Locator, URL, including the www and https://. A domain name is simply the name of your website, and the URL is the complete web address of your website. For example, if you type IBM into an address bar, most web browsers will infer https://www.ibm.com, opens in a new tab, and direct you to the IBM website. A website can be one page or thousands of pages. Each web page has a separate URL containing the same domain name as the other pages of the same site. If you know the full URL for each page of the site, you can simply enter those URLs to get to a specific page. Because this is cumbersome, most websites have a navigation structure which describes how the different pages of the website link together. Usually, the user sees the navigation structure in the form of a navigation menu. The navigation menu is a set of links with unique URLs presented in a user-friendly manner. The browser. The browser is software that provides a way for a user to experience and interact with a website. When you are interested in visiting a website, you open a browser, type in a domain name or URL, and within a short amount of time that website appears. When you request a website, the browser first makes a request to the web host for the website files. A web host, or a hosting provider, supplies the servers where the files exist as well as all the services needed to return the website to the browser. When a server returns website files, the browser interprets the files and displays this information as the user interface, UI, of that website. The server. Imagine that you are an artist, and you have some pieces of art that you want to sell. You would like to sell your art in a gallery, but you don't own a gallery. You could create a small gallery at your house, but it would not function as well as a large gallery. So, you find a public gallery that, for a small fee, will display your work and deliver it when someone purchases it. When you create a website, it is like the piece of art and a server is like a gallery. You need to upload a website to a server for it to be viewable on the internet. A web server is a special computer, or network of computers, designed to host and deliver web pages. Like the public gallery, servers have the infrastructure to deliver your website to many visitors in a timely fashion. A web development team must consider all of these components before they create a website. How is a website developed? You would not start building a house without a set of blueprints or without hiring an electrician. You'd want to inspect and test that everything is functional in the house before moving in. In the same way, web developers don't begin developing a website by writing a bunch of lines of code. They also don't publish their website for the world to see without first testing it. Let's explore how web developers get from a blank page to a fully functioning website. Review these typical, distinct steps in the web development process. Step 1. Planning and design. A group of people planning in an office. Image source, photo by Jason Goodman, opens in a new tab, on Unsplash, opens in a new tab. During planning and design, the web developer works with a web designer and other stakeholders to create requirements. These describe what functions the website needs to perform, and how it should look. Designers might create wireframes to assist with the coding process. Wireframes are diagrams that show where elements should be on a page. They include detailed information like the size of elements, how far apart elements should be from one another, and how the design should look on various screen sizes. Step 2. Coding. Two people look at code on computer monitors. Image source, photo by Sigmund, opens in a new tab, on Unsplash, opens in a new tab. This is where the web developer shines. During this step, they program the website and create code files. Web developers take the wireframes and the requirements and write the code the website needs to function. Web developers work to meet the requirements and reflect the design in software. When developers can't translate the design or a specific requirement into software code, developers might need to go back to the designer and project manager to update the design or requirements documentation. This is called an iterative process because the design and development phases undergo continual change and improvement. They might also be setting up the environment where the website will live. Web developers need to purchase and register a domain name. They also need to set up web hosting, either through a web hosting provider, or through servers at their company. At the end of this phase, web developers provide working web pages that are ready for testing. Step 3. Testing and publishing. A person coding on a laptop. When the website programming is complete, it is ready for testing and publishing. Web developers or others on the team are responsible for testing the code. The purpose of testing the website is to make sure that it is functional. This means that all links, buttons, and interactions work as expected. Web developers also test that the website meets the requirements defined during the planning phase. They also need to test that the site is accessible. Accessibility ensures that as many people as possible can use a website. This includes users with disabilities, such as a vision or hearing impairment. After the team has tested the site, it is ready for publishing. Development teams typically develop and test code on a version of the website that users can't access. This version is called the staging site. The staging site is identical to the live website in every way except it's accessible only by the development team. When the updated code, images, and other website assets are ready, a publishing team will publish or push the new files to the live site for users to experience. When updating a website or adding new features, publishers have to make sure that the live website doesn't break. A break can occur when something that works in the original website stops working or is accidentally missing in the updated website. This is why testing and a staging site both are important. By using a staging site and testing all the new code on it, development teams can avoid surprises when publishers push updates to the live site. During development, web designers and web developers work together. While the work that both roles perform isn't always linear, in general the designers and developers produce the following deliverables. Take a moment to review this diagram so you're familiar with the typical deliverables that align with web design and web development to develop a new website. You can see that the typical steps of the web development process involve a lot of work. See if you can identify some of the key tasks. Maintenance. After the site is built and published, web developers also need to maintain it. This might be implementing simple content changes and updates to images, but there can also be major updates to the functionality of the website. Some web developers focus primarily on maintenance of existing websites. Client-side and server-side processing. When you are out at a restaurant for dinner, you decide what to eat, tell your server, and then, after a period, your server brings the dish that you ordered out to your table. You interact with the server, but rarely interact with the kitchen staff. In the same way, when users interact with a website, they might give the website some instructions, say by filling out a form. But after they submit the form, the user is unable to see what happens to the information until it is processed and returned to the user's device. In web development, these two processing functions are client-side and server-side. These terms refer to which computer performs tasks. Front-end developers write the code that renders a website and also enables a user to interact with a website. Some of those interactions trigger a process that directly communicates and interacts with servers and the processes that run on them. For example, when you do something as simple as clicking the play button on a video, that begins a request to pull the data that makes up the video you want to play from the server. The server then sends that data to the client's, device to render it, a client-side process. Back-end developers write the code that processes data and performs tasks that send information to and receives information from the browser. For example, a user might use natural language to search for all restaurants in a given area. They type, Show me all the Greek restaurants in my home city into a form. This query along with some location data is sent to the server, which uses artificial intelligence and natural language processing technology to produce a result, a server-side process. The result then is sent back to the client side to display to the user. Client-side code works with server-side code. For example, if a website is designed to display banking data, server-side developers will write software that listens for data requests from the client. Client-side developers will write the code that requests the data, or they'll use software that a server-side developer has written to retrieve that data. Client-side processes. Run on the user's device. Render web page layouts and make requests from the server. Manipulate visual design elements, such as brand colors and typography. Respond to user interactions, such as buttons and form validation. Interact with server-side processes to send and receive data and process information. Server-side processes. Deliver dynamic content to websites based on user action, or data from a database. Store, manage, and deliver data to client. Authenticate user login information. Send data to and get data from client-side processes. Run complex processes that require a lot of power and send results back to the client. Check what you've learned about the functions of these two processes. About this module. Module 4. Front-end development. Introduction. In this module, you will learn about front-end web development. You'll discover the scope of front-end developers and the challenges faced by them in today's age. Furthermore, you get to explore the common languages used in front-end development. Learning objectives. After completing this module, you should be able to describe front-end web development. Identify areas where front-end development is needed today. Identify challenges front-end developers face. Identify common languages for front-end development. Overview of front-end development. Front-end development focuses on developing only the parts of a website that users can see and interact with. A front-end developer creates everything you see on a web page, such as text and buttons. Every interaction that a user has with the website is programmed by a front-end developer. As a web developer, it might sound exciting to build something that anyone on the internet can see and interact with. Digging a little deeper, you can explore more of what front-end development means for web developers. Where is the code run? The code runs on the user's device. What is the primary focus? The focus is on website layouts and visual design elements. How does front-end development relate to data? It creates interactions so that users can input data. What are the programming priorities? User experience and accessibility. Ability to use websites on multiple devices. Media renders properly. As computers have become more powerful, the role of the front-end developer has expanded. The first websites were informational, and their development was complex. Initially, front-end development was primarily focused on simple page layout and styling. Style, a collection of formatting rules that define how to display diverse types of elements on a web page. Front-end developers can now develop websites with increasingly sophisticated interactions, such as animations and 3D renderings. As technology has advanced, front-end developers have also had to consider other areas that they would not have considered in the past. Check out areas that front-end developers should focus on when creating great web experiences for everyone. Mobile ready. Increasingly, users are accessing the internet from various devices, including smartphones and tablets. Many of these devices are physically different from desktop or laptop computers. They also have unique features, such as screen orientation APIs that determine how a user is holding their device. The ability to program a website to work on both larger screens, as well as mobile devices, has led to the development of responsive web design. This is a set of techniques that enables websites to respond based on the size of the screen that is being used and how it is being held. A design is responsive when it can accommodate not only variable screen sizes and screen orientations, horizontal and vertical, but also various input types. Mobile devices such as smartphones and tablets support touch screens, and a mobile-ready, responsive design should avoid inputs that require a physical keyboard or touchpad, or mouse, to navigate. Many modern frameworks support responsive design. A framework is a software package with built-in user interface and data tools that developers can use to build websites. React, Vue.js and Bootstrap are examples of frameworks. Search engine optimization, SEO. Before the internet, if you needed a specific service, you could search for a number in a phone book. Phone books provided an index of sorts, with addresses and phone numbers of businesses. In a comparable way, modern search engines are where users go to find specific information. Search engines automatically access websites and gather information about them to create an index of all websites. This is known as crawling the web. They then use complex algorithms to sort that information and rank it. There are many factors that contribute to a website's rank, including speed, mobile friendliness, and accessibility. Web developers increasingly need to understand how to optimize their websites for search engines so that they appear higher in the rankings and internet users find their sites. Developers add metadata to the top of their web pages or websites that describes the content within them. Search engine optimization, SEO, is the process of ensuring that the metadata included in the header of a page or site matches the content in the body, adding appropriate information so search engines can properly crawl the site. Explore more. Google offers a search engine optimization, SEO, starter guide, opens in a new tab, if you'd like an overview of the ways that web developers can optimize their pages for search engines. Accessibility. Making websites easy to use for as many people as possible should be a primary goal for web developers. Websites can reach a wider audience by being accessible. Focusing on accessibility is critical to ensuring websites are usable for everyone. A website is accessible when it provides information for screen readers, such as description text for images, can accommodate those with physical impairments, such as supporting high contrast or dark modes, is responsive, such accommodating touch navigation. Explore more. The World Wide Web Consortium, W3C, opens in a new tab, develops international standards for the web. The W3C Web Accessibility Initiative, WAI, develops standards and guidelines to help you understand and implement accessibility. All web developers should check out and follow the W3C accessibility standards, opens in a new tab. Challenges front-end developers face. Developing the user-facing aspects of a website can be a rewarding experience. But front-end development does have the following challenges. Meeting technical demands. It's a challenge to meet the technical demands of designs that also meet the needs of users. Developers must make decisions within the constraints presented by technologies, design styles, programming languages, and budgets. Supporting compatibility. It's a challenge to develop a website that works consistently across different browsers. There are many popular browsers, and these even have various versions for different platforms and devices. Front-end developers must develop websites for many different browsers, which all have different standards. Some browsers do not support certain styles and features, and so the website should have fallbacks and degrade gracefully. Accommodating graceful degradation. A website should function in a limited way on older versions of browsers. Front-end developers need to keep browsers and what functions they support in mind when they are developing their site. Common languages for front-end development. Front-end web developers use programming languages to code user-facing experiences for the web. Explore these common programming languages that front-end developers use. Hypertext Markup Language, HTML. When building a house, one of the most important initial steps is framing. Framing provides the shape of the house, as well as the structural support for all other elements of the house onto which it will be built. Similarly, web developers use HTML to build out the structure of a web page. Web developers use HTML to tell a browser how to display web page elements such as paragraphs, links, and media files. Cascading style sheets, CSS. Before a house is completed, builders and interior designers focus on finishing the interior design. They may paint or wallpaper the walls, add decorative flooring, and install a backsplash in the kitchen. In the same way, web developers use CSS to add styling to a web page. CSS is responsible for the colors, backgrounds, animations, and other decorative elements on a page. JavaScript. A home would not be complete if you could not turn on the lights or use the sink. Electrical and plumbing are critical steps in the house building process, as they allow the house owner to interact with the house. Web developers use JavaScript to add interactive elements to a website. JavaScript allows web developers to extend the functionality of a web page beyond the basic HTML and CSS. With JavaScript you can add pop-ups, dynamic image galleries, and personalized content. Do you know which programming language to use? About this module. Module 5. Back-end development. Introduction. In this module, you will learn about back-end development and explore the common programming languages that back-end developers use. You'll discover areas where back-end web development is needed. And you'll also learn about how back-end developers ensure websites and systems are secure and meet security standards. Learning objectives. After completing this module, you should be able to describe back-end web development. Identify areas where back-end development is needed today. Identify the common languages for back-end development. The Internet versus the World Wide Web. Think about the city that you live in. The city is full of homes, government buildings, businesses, parks, libraries, and other recreational areas for people to meet and socialize. Connecting each of these places are streets, highways, and trails. You might use a mode of transportation like a car, bus, train, or bicycle to get from one place to another. You can think about the World Wide Web as the places in your city, and the Internet as the streets that get you from place to place. The World Wide Web is comprised of all the websites that you use to conduct business, socialize, and find information. The Internet is a network of computers and servers that provide the infrastructure for you to access the web. A brief history of the Internet. Take a moment to familiarize yourself with the key milestones in the history of the Internet. The 1960s. Computer scientists imagined the concept of packet switching. Packet switching is a method of separating data and sending it over a network. This concept forms the backbone of the Internet and is relevant today. The Advanced Research Projects Agency, ARPA, developed a plan to create a communication network that could connect computers to share information and research. They called this network ARPANET. The 1970s. Robert Kahn and Vinton Cerf developed standards for how to transmit data between networks. They called these standards the Transmission Control Protocol and the Internet Protocol, also known as TCP/IP. Distributed computer networks were developed across government agencies and academic institutions, such as NASA and the U.S. Department of Energy. The 1980s. ARPANET began using TCP/IP as the standard for data transmission. This made a way for computer scientists to begin creating a network of networks. Tim Berners-Lee proposed the creation of the World Wide Web in a document where he defined web, hypertext document, and browsers. The 1990s. Tim Berners-Lee launched the first web browser, server, and website, info.cern.ch. The World Wide Web was released and the first web server was hosted online. CERN makes the World Wide Web source code freely available. Only 1% of Internet traffic is on the www, all other traffic is on private networks. The World Wide Web increases in popularity and has 10 million users, almost twice the entire population of modern-day Costa Rica or New Zealand, and 10,000 servers. Present day. The World Wide Web and the Internet are still growing and evolving. Smart devices, the Internet of Things, IoT, and robotics all use the internet and are pushing computer scientists to find even more ways that the internet can enhance lives. Source: Brief History of the Internet, opens in a new tab, Internet Society, 1997. As you can see, the foundational work done to create the internet paved the way for the World Wide Web to exist. While you might think of the World Wide Web as the internet, in fact it is just one small piece of how the internet works. How does the internet work? You sit down at your laptop, open a browser, type in a URL, and a web page appears right away. It feels a little bit like magic. But what is really happening here? Introduction. Take a journey through the web by exploring how the internet works. You'll follow an example of riding a train. Step 1. Enter the station. The back of a router with a wire connected to it. Image source: photo by Compare Fiber, opens in a new tab, on Unsplash, opens in a new tab. To access a website, your computer is connected to the internet using a modem and / or router. Much like a train station connects you to other cities, this connection enables you to communicate with other networks around the world. A modem connects you to the internet. It is a piece of hardware that receives signals from your internet service provider, ISP, and translates these signals into a form that your computer understands. A router manages the information sent over the internet. It ensures the delivery of the right information to the intended device. A router takes the internet connection from your modem and breaks it up to provide access to the different devices connected to the network. Step 2. Get a ticket. A modern train stopped in a train station with people and ticketing machines on the platform. If you are at the ticket counter of a train station, you can request and purchase a ticket to your destination from the ticketing agent. The ticketing agent would look up a timetable to issue you a ticket for your destination. When you type a URL in your browser, you are requesting information from another specific destination. Your computer will push your request to your internet service provider, ISP, who will use a domain name server, DNS, to translate the URL into a numerical Internet Protocol, IP, address. The DNS service enables users to use friendly names in the web address of the websites they're trying to reach. Without DNS, instead of using a web address like https://www.ibm.com, opens in a new tab, users would have to remember and type in an IP address like https://23.194.240.52. DNS translates the user-friendly web address to the IP address so users don't have to worry about the IP address. A browser is the interface you use to request information, like the ticket counter. An ISP provides access to the internet, connecting you with many other networks, using many servers to transfer your data. Like how a postal service sorts mail addressed to various locations and then delivers your mail to your address, an ISP uses your IP address to deliver the right data to your router. Your ISP uses standard internet protocols to manage your personal connection and ensure that data reaches the proper location. DNS manages the mapping of text URLs and numerical IP addresses, like how a timetable maps the times and destinations of individual trains and train stations. An IP address is the unique address for a specific location on the web. IP addresses are formatted NNN.NNN.NNN.NNN, where each set of NNN is a number between 1 and 255 to 256, per 8-bit field, totaling 32 bits. IP addresses are like your train ticket that identify the destination of your trip. Step 3. Load your bags and settle in. A person working on a laptop. Image source: photo by Anastasia Nellin, opens in a new tab, on Unsplash, opens in a new tab. After you receive your ticket, you would load your bags on the train, board, and settle in for the journey. In a comparable way, your browser will break your request into smaller manageable pieces using the Transmission Control Protocol, TCP. TCP is an internet standard that defines how computers should break up data and send messages to one another. TCP and IP are the two basic standards that define the Internet. Step 4. Enjoy the journey. A person browsing the Internet. Image source, photo by KOBU agency, opens in a new tab, on Unsplash, opens in a new tab. Once your message is in the correct format and knows where it is going, it takes the quickest route through the network of networks to reach its destination. Summary. This example of taking a journey on a train demonstrated how the Internet works. Web development and cloud computing. In the early days of the Internet, individual, high-powered computers did all the work needed to support web pages and store files. These computers were the first web servers. An individual server might have a few websites running on it. The disk drive on that computer stored all the files needed for that site. In the early days, it was common for small businesses to have their company's websites running on a server under someone's desk. Imagine how fragile that was. What is the cloud? As Internet technology evolved, hundreds and then thousands of servers networked together to share the tasks, or workloads, involved in delivering hundreds of websites and services. These became known as server farms. Further evolution enabled the separation of the actual hardware functions. Cloud computing, or simply the cloud, is an evolution of these server farms. Early Internet servers were designed to deliver websites with all the services that a website needed, like storage, networking, and security. All these services were included on a single server machine. Cloud computing improved on that model by separating the features of one server into separate functions on specially designed and dedicated servers. This makes it easier for web developers to use only the resources they need, when they need them. Today, cloud servers are built to perform one of a range of specific hardware functions like storing large amounts of data and rapidly reading the data from and writing it to disk drives. Processing data. Providing computing power. Handling networking. Running specialized software. How does the cloud help web developers? Many websites are hosted in the cloud and use cloud services. Explore ways web developers can use the cloud to build scalable, robust websites. Host websites. Web developers can use the major cloud providers like IBM, Amazon, and Google to host websites. By hosting a site in the cloud, web developers can take advantage of a worldwide network of computers that can make their sites fast and available to people around the world. Many cloud providers also offer services such as security certificates, database storage, domain name hosting, and artificial intelligence services that web developers can use on their own sites. Distribute workloads. Imagine you're on your favorite banking website. You want to add another account from a different provider so you can keep track of your spending in one place. As you add the account, the website fetches account data from another provider, such as your credit card company, and the data appears in your banking application. The service that fetches the data might not be on the app installed on your phone. Instead, the website calls out to software on the cloud which has the conversation with the credit card company and returns the data securely to your phone. By distributing software workloads in this way, web developers can keep websites smaller, reducing download and load times. It also enables developers to more easily update key functionality. If the software that retrieves data is on servers in the cloud, developers can update that software and the apps on users' phones can use it immediately even if the application that uses it wasn't updated. Web developers refer to a website calling software in the cloud as making an API call. Store and distribute data. Most websites use data and web developers need databases to scale to meet website needs. There are many database solutions on the market, both open source and proprietary. Cloud providers offer a wide range of options to meet the needs of websites that range from small hobbyist sites to the largest enterprise sites. Cloud providers also support binary large object, blob, storage. A blob is a large file storing binary data, such as an image, video, or any file that contains more than plain text. Cloud providers offer optimized solutions to store and move blobs between servers and users. Web developers use blob storage to host catalog images, videos, documents, and application files that they deliver from their websites. Scale based on need. In the days before the cloud, if you needed more power on your computer, you either had to upgrade, buy another computer, or borrow one. This was really inconvenient if you only temporarily needed the extra power. And many people overbought, spending a lot of extra money on power they never used or needed. The cloud has helped address the scale problem. Many services are available in the cloud now, where businesses and individuals can pay for only the capacity and power they use. If a web developer needs more storage, they pay for it when they need it and can scale back when they no longer need it. If a media company is having a big event like a major sporting competition and expects streaming demand to be high on a given day, they can use cloud services that automatically scale up when demand is high and scale down when it gets back to normal. This makes for a better user experience because the company doesn't experience broadcast outages and the streaming capacity automatically adjusts to demand without the company having to manage it. Because of scaling, as demand grows, the performance and availability of the site and the services the site provides remain consistent. You've come so far and learned so much. You've explored basic computer functions and programming languages. You've learned about web development and explored the differences between front-end and back-end development. And you've learned about the differences between the Internet and the World Wide Web. Now that you've completed this course, you should be able to describe the basic functions of a computer. Differentiate between hardware and software. Describe the types of programming languages. Explain how a computer reads code. Differentiate between web design and web development. Identify website components. Explain the main steps in the web development process. Differentiate between client-side and server-side processes. Identify the focus areas and common languages for front-end development. Identify the focus areas and common languages for back-end development. Differentiate between the World Wide Web and the Internet. Explain how the cloud benefits web development. Key points to remember. 1. No matter the size, all computers have 4 basic functions: input, processing, output, and storage. 2. Binary code, also known as machine code, is a system that represents all data as either 0s or 1s, false or true. It is the only language that a computer can understand. 3. Computers need hardware, the physical components, and software, the instructions, to accomplish the 4 functions. 4. The concept of abstraction makes it possible to give a computer instruction without understanding the sheer complexity of the machine by hiding unnecessary details. 5. A compiler translates human-readable code into machine code by checking the syntax and translating human-readable code into binary code. 6. The web development process consists of planning and designing, coding, testing, and publishing, and maintenance. 7. Client-side programs run on the user's device, while server-side processes run on website servers. 8. A front-end developer creates everything you see on a website, such as text and buttons. 9. A front-end developer primarily uses HTML, CSS, and JavaScript to build websites. 10. A back-end developer writes code to power the front-end experience, including data management, and server responsiveness. 11. A back-end developer uses JavaScript, Python, and Java to develop programs. 12. The World Wide Web is comprised of all the websites that you use. The Internet is a network of computers and servers that provide the infrastructure for you to access the web. 13. Web developers can use cloud services to help them to build scalable, robust websites.